Welcome to Study Loop.
Let's find the partial fraction decomposition for both of these functions, and there's no need to determine the numerical values of the coefficients. So looking at the first fraction, the first thing that I noticed is that the numerator is a higher degree than the denominator. And so anytime the numerator has degree equal to or larger than the denominator, the first thing we should always do is long division, or polynomial division, and that's what we have set up over here on the right. So we'd like to find the quotient here. So we have an x squared, x to the fourth, so we get an x squared up here, and then we multiply 2x cubed plus x squared, and then we subtract the whole thing. Doing so, we have a lot of cancellation here. And then we're just left with 2x minus 1. Now, this quadratic that we're dividing by does not go into 2x minus 1. So we have, for part A, we can rewrite this as the quotient, which is x squared, and then we have the remainder over the thing that we originally divided by. This is why the long division is useful. Now, every time we finish long division, the denominator will have larger degree than the numerator. And now we do partial fraction decomposition. So, as before, the first thing, always look at that denominator, see if it can be factored. Here we can factor this as x minus 1 squared. So this is what the book calls case 2. This is the repeated linear factor, which in this case is just x minus 1. So using the formula for case 2, x squared, this is not a fraction, let's just write that as it is. And then for this fraction, we have a over x minus 1 plus b over x minus 1 squared. And that'll be our partial fraction decomposition for part A. Let's go to the next page for part B. So for B, x squared minus 1 x cubed, x squared, and then x. So we notice that the denominator has degree larger than the numerator. That's good. No division necessary. Might be helpful to factor the numerator, but really more concerned with the denominator, unless we could factor things out. So maybe I should go ahead and actually do this. Not always useful, but it can be helpful sometimes. You might be able to cancel things out. But in this case, it doesn't look like that'll happen. In the denominator, let's take out an x. And there's our factorization. This term we can't factor, it's a linear, but then the second term, this may factor into two linears. So we need to look at the discriminant, b squared minus 4ac, where again, these coefficients are coming from just some polynomial of this form. All right, in our problem, we see that a equals b equals c equals 1. So that b squared minus 4ac is negative 3, which is less than 0. And that tells us that this polynomial does not factor. This guy up here. So that puts us in case 3. This is the case in which we just have a quadratic that doesn't factor, not repeated. So this is what the text is calling, the textbook is calling case 3. Now, For the first term, I see a x, so I just have a constant over x. And then for the next term, because it's a quadratic on the bottom, it's not enough to have just a constant up top. You need a linear polynomial. So that's where I'll put bx plus c. And there's our answer, part B.